Okay guys, in this video I'm going to explain you the centripetal acceleration. So again, if you have guys any questions, you can always email me. Eventually we will have some live video chats, but for now we're going to stick to the pre-recorded lectures. And so let's start it. All right, so why the acceleration is called centripetal acceleration, and let me just explain you guys in this video. So I'm gonna draw a circle to my best abilities, of course. I'm not a great drawer, but I will try my best here. And so I'm gonna find the center of this circle here, and then I'm gonna choose just 2 points on this particular circle here, and the circumference of the circle. And this will be radius here, some vector of radius, and so will be in here, some radius here, same, of course, equal magnitude. These two radius, of course, are equal. It's a circle. And I'm gonna now draw the vector of the velocity here, initial velocity, so it has to be a tangent. So let me draw the tangent to my best abilities here. There you go. So this is v sub 0, and so my next velocity will be another tangent. It will be going now downwards. Let me erase this. Again, it's a tangent. It's just touching the one single point on this circumference of the radius, of the circle, and there will be 90 degrees. I did it purposely here. It will be perpendicular. Here is also 90 degrees. 90 degrees will be going downwards right here. It has to be the same magnitude here. Same magnitude. So V final. Okay. So even though the vector of the velocity has the same magnitude, the acceleration will be here, not a zero here. Not a zero. It will be whatever the body that you rotate around in the circular motion will have constant acceleration, because even though the magnitude of the vector will be the same, but the direction of the vector will be different, and therefore you will have some constant acceleration here. So how do we find out where acceleration, the direction of the acceleration, and therefore direction of the force? And here's what we're going to do: is we're going to add these two vectors, or in other words, we are going to subtract these two vectors, because we need to find the delta V, change in the velocity, and change in the velocity is V final minus V initial. And the way we subtract the vectors, we actually add the vectors, if you remember, guys, from our previous discussions. And so that's what we're going to do here now. All right, so I'm going to take one of the velocity vectors here. Things are falling apart here. This one I'm going to take out of this circle. Let me just do it. As long as I keep the same direction, the magnitude of this vector, I'm allowed to do this. So direction is downwards. So let me try to draw the best of my ability the same magnitude, same, same length of this vector. So that looks V final. That looks like it. And now this vector, again, as long as I keep the same direction, same magnitude, I will add these two, plus, let me just draw this vector same direction. So it is looking like this. Same direction, same magnitude, same magnitude. Okay, so this is V initial. But remember, I have to plus minus. So what I'm going to do now, because this is now parallel here, so what I'm going to do now, I have to now transfer this vector parallel to this and do the following and change its direction, because we need to have a negative VI here. So this is what I'm going to do, guys. So I'm going to draw the parallel, now this vector to this with the same magnitude. I'll do my best here. Let me see. Yes, it's getting there. Let me just make sure. Not an easy task. It has to be the same magnitude as somewhere like this. So it looks like about the same. So now this is minus V initial. Again, I just transferred this vector into here, and the flipped this vector, because we need to find the delta V. And so my next move is, remember guys how we connecting the two vectors after we subtracting one vector from another. So we're going to do from the tail of the first vector to the head of the second vector. There it is. And so what we got here is a delta V. Delta V, that's what we wanted to get in here. And look at where the acceleration now is pointing. The acceleration now has to be in the same direction as the change in velocity, and it's pointing pretty much towards the center of this circle here, A. And remember guys that the force has the same direction as acceleration. So this is why the acceleration is a centripetal acceleration, because it's trying to get to the center of the circle. And so does the force now. It has the same direction as the acceleration and the change in the velocity. And that's why this is called centripetal acceleration, and this force also is called centripetal force.